Understanding lags. First, a short definition on lags to make sure we are all in the right class. Lag is a snapshot of one or more key figures at a given point in time, typically used for demand planning purposes. It is relevant to the lead time from order placement to order delivery. For example, if the lead time of an order is 3 months, then the relevant consensus demand snapshot would be lag 3 months. If you need to order 3 months ahead of time, you want to measure yourself on what you thought your consensus demand quantity was 3 months ago. Second, IBP handles lags a little differently than what you might be used to. One, lags are taken every calendar week. 2, lags are stored in technical weeks. 3, lags are on multiple key figures. 4, lags are forward-looking. 5, we have a lag from 0 to 21 weeks. So number 1, lags are taken every calendar week. Instead of once a month, they are taken at the end of every week, usually Friday night or Saturday. 2, lags are stored in technical weeks. Like most demand planning key figures, these values are stored at technical week plus product plus location plus customer shipped to. 3, lags are on multiple key figures. Lags are taken on the following key figures, subject to additions. Statistical forecast quantity, consensus demand quantity, consensus no promo quantity, statistical forecast best quantity, and consensus demand final quantity. 4, lags are forward-looking. IBP goes out into the future periods and saves the snapshot. Some designs have you saving snapshots in the past and moving them around. 5, we have a lag from 0 to 21 weeks. Due to some significant lead times, the design takes a snapshot from 0 to 21 weeks. Here's an example. A very simple example of consensus demand for the next 6 calendar weeks. Current week is December 30th, 2019. So at the end of the week, we want to take a snapshot of this key figure. Here we have a new key figure called Consensus Demand Quantity Snap, a new attribute called lag, and this looks a little confusing the first time you see it, but all IBP is doing is going out a specific number of weeks and saving a snapshot of consensus demand quantity. So this value is saying, I'm going to go out 2 weeks and copy the consensus demand. Here we have lag 2. We're here in the current week. We go out 1 week, go out a second week, and copy that value down. But now it's a new week, January 6th, 2020. And the demand planner decides to double their current and future demands. Demand has been doubled for current and future periods, not the past. At the end of the week, we want to take a snapshot of this key figure. Again, a little overwhelming at first, but easier to understand if you break it down one step at a time. Here we have 260 in the second week. For lag 2, I'm going to go out 2 weeks from the current week and copy the most current consensus demand quantity. So we're on lag 2. We start here in the current week. We count out 1 week, 2 weeks, and then copy the 260 down. Rinse and repeat. A new week, January 13th, 2020, and the demand planner doubles their demands again. Doubled consensus demand quantity. End of the week, we take a snapshot. Here's a snapshot at the end of the week. Again, for lag 3, we count 3 weeks from the current week and take the latest consensus demand quantity. So there's the current week, count out 1, 2, 3, and copy the 600 down. Next week, January 20th, we double the demand. End of the week, we take a snapshot. Okay, you get the idea. Here's the rest of the chart. We doubled demand every week and took a snapshot. So let's check to make sure we understand what it all means. For the week of January 20th, 2020, we can say the current consensus demand is 1,040. The consensus demand from the last snapshot, Friday, is also 1040, simply because the demand planner has not changed the demand from Friday into whatever day we're looking at this data. Last week, the consensus demand was 520. 2 weeks ago, the consensus demand was 260. And 3 weeks ago, the consensus demand was 130. And this makes sense since we doubled the demand every week. Keep in mind that snapshots are taken weekly, but the data is stored in technical weeks. So instead of the data being stored like this in calendar weeks, it is actually stored like this. You can see at the top the technical weeks, and I combined technical weeks that crossed over 2 months. That makes things interesting for a month. But first, let's assume for our example that we were capturing lags earlier. Anything in red are new values that I just dropped in. But they mean the same thing. 3 weeks earlier, I thought our demand would be 28. Okay, back to month. What did we think our consensus demand would be for January 20th back in December of 2019? Here's the data. Did you get 215? 6 plus 14 plus 30 plus 65 plus 10 equals 215. Or the technical week of 1B, technical week 2, technical week 3, technical week 4, and technical week 5A. There you see it in green. In IBP, though, you could just make a simple planning view. First, make a monthly time bucket. So your data would look like this. And put a filter in your planning view with a lag equal to 4. You would end up with a planning view like this. Which is a good reminder. When using any key figure with the word snap in it, which indicates it's a lagged key figure, always make sure you're filtering by one lag. Or using the attribute lag. Otherwise, you could end up with some really huge numbers. Because IBP would be including all the snapshots into one key figure. Or another way to think about it, this data becomes this. Extra credit. A 1 month lag is not even close to a 4 or 5 week lag. So going back to our January example, a 1 month lag would have been taken for the entire month of January on December 1st, 2019. Whereas a 4 week lag would have been taken 4 times throughout the month of December. So this week would be identical to a 1 month lag versus a 4 week lag, since they were taken at the same time. But this week would have been saved on December 1st in a 1 month lag, versus on December 30th for a 4 week lag. This 100, which was saved on December 30th for a 4 week lag, would have actually been closer to 6 on a December 1st 1 month lag if we continued with this demand planner doubling their demand. So here we have the values for a 4 week lag of 215. But if I did a 1 month lag, it would have ended up being 24. Obviously, this is an extreme example. Demand usually doesn't double every week, but you get the point. One month lag does not equal 4 week lag. Thanks for checking out Practical IBP on YouTube, and make sure you subscribe to stay up to date on the latest videos. You can click on any of the surrounding videos to learn more.